All right, now let's go ahead and take a look at this next problem, guys, number 19, where in this case we want to go ahead and determine the length of the diagonal, which is D, in our rectangular prism. We do want to go ahead and round our answer to the nearest tenth. Now, this goes back to a worksheet we did a while back. I believe this was about 7.2, where in this case we have to put a little bit more imagination onto what we want to go ahead and solve. So because we're looking for D in this case, I want to go ahead and look if we're able to find a right triangle, okay? So starting off, I could actually use this height to be part of our triangle. And I'm also going to go ahead and be using the diagonal in this case, which is what cuts in half our bottom face or bottom rectangle here. All right, so it's that there, right? So I know this one here is 2 just because this one over here is also 2. But we don't know in this case what this section is. I'm actually going to go ahead and see if I could do that in red. A little bit bolder. We don't know what this is here. All right, we don't. However, because this here is a rectangle, I know that if I focus, I'm going to actually draw a red rectangle here. Red triangle. If I focus on this one here, I could actually solve that, assuming this here is a right angle. Okay, assuming this here on the bottom is a right angle. So we're actually going to go ahead and focus on that. We're going to go ahead and actually have to solve for this side here once again, that side first, and then we'll go ahead and use that to solve for D. All right, so I'm going to go ahead and actually draw the triangle on the outside here. We have something like this, probably drawing it, drawing a little bit better here. Once again, that would be a right angle. This is what we're looking for. This is what we have. All right, so this one's actually 2 triangles that we have to use, apply for that Pythagorean theorem in this case in order for us to determine that side, that D. So in this case, just to start off, this one here is representing the hypotenuse, which is C. This is C. The other ones in this case would be A and B. So let's go ahead and do 7 squared plus a 4 squared equals an x squared. All right. 7 squared is 49 plus 4 squared is 16, which equals x squared. So then 49 plus 16, I know that is a 5. So that's probably 65. Let's just double check, guys, because I could be wrong sometimes. 49 minus 16, no, plus 16. That's going to give us 65. That is correct. And that's x squared. Now, because we want to go ahead and get rid of the square, take the square root, and x in this case equals the square root of 65. Now, in this case, guys, I'm not going to simplify my answer here as a decimal just because I want to go ahead and keep my answer as exact as possible until we reach our final answer. So this one here, in this case, guys, is representing this, which is actually representing the section that is highlighted in this case over green. All right. So now we're focused on this triangle. I'm going to go ahead and draw the triangle over here now. We're focused now on this triangle where this is 2 and this is D. And this section here is now that one there. So let's go ahead and do that. That's going to be the square root of 65. So in this case, once again, here is our right angle. So in this case, this makes that the C. So let's go ahead and use Pythagorean theorem here. So I have a square root of 65 squared, because that's representing A, plus 2 squared, which is B, equals D squared. Now, 65 squared in this case, it actually cancels out, and we're just left with 65, plus 2 squared is 4. So that's going to give us D squared, which in this case gives us 69 as D squared. From there, we do take the square root, and in this case, D, where am I? D is equal to the square root of 69. Or if we approximate to the nearest tenth, square root 69 is 8.3. 8.3. And that would actually be our answer, guys. That would be our answer. So that is a work. And that is D. All right. Moving on to the next one in this case, guys. Number 20 is actually using basic Pythagorean theorem. I'm actually going to go ahead and skip this one. Now let's go ahead and take a look at this one here. This one says we have another cross section showing an isosceles triangle. It's a triangular prism. What is the slanted height of H? So in this case, we're looking to find this here. All right. Now, once again, guys, the only way for us to actually find this is using Pythagorean theorem. So we do have to focus in this case on a triangle that has 90 degrees. Notice this here, 90 degrees, all right? Now, I know in this case that the whole section is 6, but I only want half of it because it does have it being cut in half here. We're going to go ahead and assume that that's half. So in this here is 3, and this here would also be 3. Now, if we know in this case the other slanted height, which is this one here, this is actually going to be 3 square root of 2, just because this one is also the same. So let's go ahead and take a look at this here. First of all, identifying your C is the side that's opposite to the hypotenuse, so that is C. The other ones in this case would be A and B. So let's go ahead and do 3 squared plus H squared equals 3 square root of 2 squared. This one's going to be a little interesting. Now, 3 squared in this case is a 9 plus an H squared equals. In this case, that squared, you actually do have to multiply or distribute it to both of them. So 3 squared in this case is a 9. And then square root of 2 squared is 2. All right, or just to show you guys, let me actually break it down. This is going to be 3 square root of 2 times 3 square root of 2. So then this here is going to become 3 times 3 is a 9 times the square root of 4. Square root of 4 is 2, so that's going to be 18. So I'm actually going to write that on the bottom. I have 9 plus H squared equals 18. From there, I want to go ahead and subtract the 9. And we have H squared equals a 9. So let's take a square root. And H in this case equals a 3. So our slanted height in this case, guys, is going to be 3. All right. Now, let's go ahead and take a look at the next one, guys. The next one in this case says that we do have a table that talks about, in this case, angles that are 55, 65, and 75. And then each of these angles does have different ratios. So starting off with the first one in this case, guys, we do have the adjacent over the hypotenuse. So when we're looking at the triangle, we do have to identify our sides in this case in order for us to determine what it is that we're talking about. We also have the opposite and the hypotenuse. And then we have the opposite and the adjacent. Now, based on that, for example, if we're given one of the angles, then we're going to go ahead and focus on the column of the angle, right? If in this case we're focused on a certain ratio, then we're going to go ahead and focus on this here to determine the angle. So, let's go ahead and check this out. Starting off with the first one in this case, guys, it says use a table to approximate the measurement of angle D in the triangle below. So in this case, we are trying to look for angle D. All right, so we're looking for angle D in this case. Now, because we're looking for angle D, I actually want to go ahead and determine the name of the sides that we're given. We're given this side and we're given that one there. So to start off, 6.1 is actually representing the side that is opposite to our given angle. the 6.7 is actually opposite to the 90, which is the hypotenuse. So in this case, question for you is, if we take a look back at our chart, which ratio shows opposite and hypotenuse? And in this case, opposite and hypotenuse would actually be this one here. Focus on this one. So let's go ahead and calculate that, do that fraction, simplify it, and see which one it gives us. So that's going to be opposite over hypotenuse, which in this case would be 6.1 over 6.7. If we simplify that, let's go ahead and do 6.1 divided by 6.7. And that's going to give us about 0.91. If we take a look at the chart here, which one gives us 0.91? And it's actually this one here. So then the angle is 65. Angle D, measurement of angle D is 65 degrees. All right. Take a look at the last one here. In this case, guys, it says use the table to approximate, in this case, MO and the triangle. So we're looking for MO. We're looking for this side here. So I'm going to go ahead and actually put an X on the side that we're missing, or we want to find. And we're working with the angle that is 75 degrees, all right? So because it's 75 degrees in this case, we're going to go ahead and be focused on this column here, all right? Now, in this case, because of the 75 degrees, we're not given the opposite side, but we know that that's going to be the opposite. So in this case, that makes the 2 to be our adjacent side. Same thing with the 90 degrees. 90 degrees is opposite to X. So therefore, this is the opposite. Now, in this case, we're looking for a fraction that has adjacent, sorry about that. Okay, where are we? Okay. That has, in this case, the adjacent over the opposite, or the other way around, actually. Oh, wait, this doesn't make it the opposite. I just noticed that. Typo. This is a hypotenuse. So in this case, that is going to be the hypotenuse. All right, so let's go ahead and take a look at this here. ADJ and hypotenuse. So in this case, our answer technically should be, well, not technically, but we need to use the 0.26 as our answer. So we know that whatever we get there, that's going to be 0.26. So let's go ahead and substitute those values for these two. So that's going to become 2 over x equals 0.26. Put this over a 1. Let's do cross multiplication. And we get a 2 is equal to 0.26x. Final step is to leave the x alone, divided by 0.26. So, in this case, I have 2 divided by 0.21. So, x, in this case, is going to equal 9.5. And that would actually be our final answer.